Hello guys. So in this lecture, next we are going to start a beautiful chapter that is called stability analysis, right? First of all, what is the purpose of stability analysis? Already we had been discussed about fault analysis, right? And I have been told you what is the purpose of fault analysis. In our power system, the problem in our power system is if there is any fault. Now for transmission line we have seen there are many possibilities like line to ground faults are there, line to line fault, double line to ground fault, triple line to ground fault. So அந்த மாதிரி ஃபால்ட்லாம் நடக்கும்போது என்ன நடக்கும் அப்படினா our equipments, right? So நம்ம சிஸ்டம் வந்து கொலாப்ஸ் ஆக சான்சஸ் இருக்கு, ரைட்? So அந்த மாதிரி சான்சஸ் எதுவும் நம்ம கிரியேட் பண்ணி கொடுத்துட கூடாது. லைக் இப்போ ஏதோ ஒரு ஃபால்ட் நடக்குது, ஏதாச்சும் ஒரு அப்நார்மல் கண்டிஷனுக்கு சிஸ்டம் போகுது அப்படினா அந்த டைம்ல அந்த ஃபால்ட் லெவலோட சிவியாரிட்டி தெரியணும் நமக்கு. அண்ட் செகண்ட் திங், அந்த சிவியாரிட்டி தெரிஞ்சாதான் அதுக்கு ஏத்த மாதிரி எக்யூப்மெண்ட்ஸ் வந்து நம்மளால ப்ரொவைட் பண்ண முடியும். லைக் தி சர்க்யூட் பிரேக்கர் மேக்கிங் கெபாசிட்டி அண்ட் பிரேக்கிங் கெபாசிட்டிஸ் and relays oda current rating, so everything we have to fix with the help of stability analysis, right? With the help of fault analysis. Appo fault analysis oda main motto enna to identify the fault level, right? Or line வந்து சடனா fault ஆகுதா, அது என்ன fault, line to ground fault இல்ல double line fault இல்ல double line to ground fault. So based on the nature of the fault, what is the maximum amount of fault level or fault current that can pass through the transmission line during the fault. அதை ஐடென்டிஃபை பண்ணி previously நம்ம என்ன பண்றோம் அப்படினா proceeding in advance we are trying to keep the protective elements in our transmission line so that though there will be some problems in my system, your circuit breakers and the relay will try to operate and it will isolate the faulty zone. Clear? So அப்ப சிஸ்டம் வந்து திரும்ப நார்மல் ஸ்டேட்டுக்கு வந்துரும். But the problem is அந்த fault நடக்கும்போது அடுத்து வேற என்ன issues இருக்கு. So here we are now in our transmission line, right? In our transmission line it will be there are lakhs and lakhs of alternators are connected in parallel. So I can say, sir, thousands and thousands of alternators in India has been connected with our national grid in parallel, right? So if all these alternators are right working under normal state la work பண்ணிட்டு இருக்கா, when the moment there will be a sudden problem ஒரு fault நடக்கும்போது we know circuit breaker will going to isolate the fault, yeah, something is going to happen, but during that malfunctioning, during that huge response, during that fault condition, who is going to take the responsibility to deliver the fault current? Alternator, of course, sir. அப்ப fault நடக்கும்போது visa fault level of the current வந்து நம்ம பார்த்தோம், but who is taking the responsibility to know the magnitude of the fault level and the fault current வந்து supply பண்றது, who is taking the responsibility? That is my alternator, right? So இப்போ நம்ம என்ன பண்ண போறோம்னா, again, whenever my system undergoing to some huge disturbance like some electrical fault or some mechanical disturbance, right? So அந்த மாதிரி problems வரும்போது, however alternators are experiencing the disturbance அப்படிங்கறத பத்தி பார்க்கலாம் அந்த stability analysis. Okay, however alternators are stabilizing, however alternators are synchronized, however alternators are scattering the disturbance, அத பத்தி நம்ம clear-ஆ analyze பண்ணி, right, in how way, in which angle, in which point of view my alternator will be stabilized, in which point of view எவ்வளவு angle வந்து நம்ம மெயின்டைன் பண்ணா நம்ம சிஸ்டம் வந்து ஸ்டேபிளா இருக்கும். So that things we have to analyze. Okay, let us see one by one. So first of all I am giving a small introduction. So the conclusion is, whenever while going with the alternators, let me take some huge alternators are connected in parallel in our national grid, right? Now what will happen, sir? Actually you can experience there are two type of disturbance in our alternators, right? So one வந்து பாத்தீங்க அப்படினா அப்ப alternators வந்து light disturbance will be, there may be a chance for light disturbance. Of course there will be one more disturbance that is called a large disturbance. So based on the nature of the disturbance, in the light disturbance அப்படிங்கறது or small disturbance அப்படிங்கறது, that small perturbation will always exist with our alternator. அப்படினா மீனிங் என்ன அப்படினா நம்ம சிஸ்டம் வந்து ஸ்டெடி ஸ்டேட்ல இருக்கும்போது என்ன ஆகும் அப்படினா some small disturbance, some small abnormal conditions, uncertainties which will be always there in our system in practicalities, right? So the practical constraints, the practical small disturbance cannot be avoidable, that is unavoidable. We must go along with that small disturbance, and all the alternators, our power system equipments are accepting those small disturbances, and our system is it is keep on going with this small disturbance. That is called small disturbance means steady state analysis. Steady state means our system in normal conditions, sir. With that I am getting some small disturbances. Okay, that is one thing. And the second thing is, while discussing about the large disturbance in the sense transient analysis. Transient அப்படினா this now first சொல்ற small disturbance, that small disturbance will exist only for a particular time period, whereas large disturbance in the sense a big disturbance, right, அது எங்க appear ஆகும் அப்படினா it will exist only for a short duration in our power system, but the equipment that if you see the fault level of that large disturbance, that is enormously very high, and the disturbance created by the large அப்படினா suddenly there will be a fault in my power system due to some lightning or some other reasons, right? Some other issues are happening. That abnormal large disturbance will create a huge disturbance, right? That abnormal condition will create a huge experience for your alternator. அப்ப அந்த டைம்ல நம்ம alternator வந்து எப்படி வந்து work பண்ணும்? You know one thing guys, listen. We all know alternators are connected in parallel. You know, alternators are connected in parallel. In the same way, our transformers also connected in parallel. If you take, sir, two transformers are connected in parallel during the fault. If there is any malfunctioning in any one transformer, that one transformer will be completely removed, and because of that one transformer fault or because of the abnormal condition of a single transformer, none of the transformers are going to be affected. This disturbance, if transformer 1 வந்து failed ஆகுதா, if the transformer 1 is undergoing the abnormal condition, we can simply remove that transformer, and the rest of the transformers are working under steady state, and the rest of the transformers does not experiencing any disturbance because of the abnormal condition of the single transformer. So the conclusion is, in alternator, if you look at the parallel operations, if you look at the parallel operation, sir, I have 10 transformers and 10 alternators. Let us assume first transformer எடுத்துக்கலாம். Sir, 4 transformers are connected in parallel. Now one transformer undergoing the abnormal condition. Now this abnormal condition does not affect your nearer transformer. You can simply remove it from the system. But this is not the case when we are discussing about our power system. In our power system, you know what will happen during the fault. Not only a single transformer will going to take during the fault, not only a single alternator will going to take responsibility for the fault zone, since all the alternators are connected in parallel. So whichever the alternator that are connected in parallel with our national grid, that all the alternators will experiencing the disturbance when your system undergoing to abnormal case. So I hope you all understand. For an example, sir, there are 10 alternators. All the 10 alternators are connected in parallel, sir. Now what will happen? Right? If all the alternators are connected in parallel, if there is any one problem in a single alternator, that problem is very huge. Guys should try to understand. If the problem is very small, if the disturbance is very small, then that will be negligible. You don't need to consider the rest of all alternator. Okay, there is any problem, that problem is very small, and if this single alternator is getting affected by a single disturbance, okay, you don't need to consider, we can neglect it. In such a case, we are considering a single alternator. Only the single alternator is getting affected by the small disturbance, small perturbations. Just we are analyzing the single alternator. Okay, what's happening inside the alternator because of the small disturbance. Okay, sir, that is no problem. That is called steady state stability. But under transient zone, if the one alternator is getting affected by a huge disturbance, then this huge disturbance will be this alternator. Once in the alternator என்ன ஆகும் அப்படினா ஒரு transient stability அப்படினா ஒரு large disturbance ஆல affect ஆகும்போது, that large disturbance இந்த alternator என்ன பண்ணும் அப்படினா it will be அந்த disturbance வந்து மத்த எல்லா alternatorக்கும் scatter பண்ணி விட்டுரும். So are you getting me? So what I am trying to conclude, small disturbance in the sense there is no problem. Large disturbance in the sense one large disturbance will be completely scattered to all alternator. Not only a single transformer, a single alternator will going to take responsibility for the transient state, right? There are whichever the alternator that are connected in parallel, all the alternators will going to, right? All the alternators going to take the responsibility for the large disturbance. So the disturbance will be scattered to the all alternator. When a single alternator is getting affected by a huge disturbance, that single alternator disturbance will be scattered, it will be spread to all the alternator whichever connected in parallel with that single alternator. So that is called transient stability. Of course, if you observe this stability, we are going to look at there are 3 types of stability. One is called frequency stability. That is, we have to see under the faulty condition, right? What is the fluctuation in the voltage, and we have to look at the frequency. We all know in our national grid, in our Indian system, our frequency is only 50 Hz. Now we have to see what is the fluctuation in my frequency, right? And the last type of that, so first one is voltage stability, second one is frequency stability, and the last one is dynamic stability, or it is called angular stability. So now in our syllabus, we are going to keep our attention with only about dynamic stability or angular stability. Voltage fluctuations is very small and it is negligible, and frequency fluctuation is very small, that is also negligible. But we should keep our attention with the angular stability or dynamic stability. That is what we are going to discuss in our entire stability analysis. Okay guys, now let me slowly enter into the concept. Now what I have been told you, sir, if 10 alternators are connected in parallel, when one alternator is getting affected by a large disturbance, that large disturbance will be scattered to all alternators. Okay sir, that is correct. அப்படியே அந்த disturbance வந்து scatter ஆகுது. அந்த disturbance வந்து மத்த எல்லா alternators என்ன ஆகுது அப்படினா they all are going to experience something, some new experience they are going to get when the moment a single alternator is getting affected by a large disturbance. அப்ப மத்த alternators எல்லாமே வந்து எப்படி disturb ஆகுது? They are experiencing like that. So some disturbance they are going to experience because of this single alternator, because this single alternator does not creating the disturbance. The disturbance created by someone outside, but the disturbance will be scattered. This alternator will spread to the disturbance. எல்லாருமே disturbance வந்து spread பண்ணி விட்டுரும். நான் மட்டும் ஏன் வந்து இதை எக்ஸ்பீரியன்ஸ் பண்ணனும், நீங்க எல்லாரும் எக்ஸ்பீரியன்ஸ் பண்ணுங்கன்னு சொல்லிட்டு that disturbance will be scattered to all alternator whichever connected in parallel with the single alternator. Okay sir, of course the conclusion is over. Now there are two type of disturbance. அதுக்குள்ள பாத்தீங்க அப்படினா அந்த disturbance வந்து ரெண்டு விதத்துல வந்து நம்ம alternators எக்ஸ்பீரியன்ஸ் பண்ணுவோம். இப்போ நம்ம என்ன பண்ண போறோம் அப்படினா, so first let me take 10 alternators for understanding. 10 alternators I am considering here, and I am assuming all these 10 alternators are connected in parallel. Now alternator 1 is going to affected by a large disturbance. Of course this large disturbance will going to be scattered for the rest of 9 alternators. Now this remaining 9 alternators together they are going to experiencing the disturbance because of the large disturbance affected by the single alternator. In the single alternator வந்து spread ஆகிற disturbance in the 9 alternators வந்து together they are going to experience. அப்ப இந்த 9 alternators நம்ம என்ன ட்ரீட் பண்ண போறோம் அப்படினா, we are going to treat them as a single alternator, because taking single alternator, taking this 9 alternator and going one by one and looking at the disturbance, what is happening in the second alternator, what's happening in the third alternator, that task is tedious. If you go with our national grid, there are thousands and thousands of alternators are connected in parallel. Can you go with all the alternators? Let me select the first one, second one, what is the disturbance in the third alternator because of the first one, what is the disturbance in the fourth alternator because of the first one, what is the disturbance in the fifth alternator because of the first one? Can you go up like this? That is not possible. So what we are trying to do, we people are usually trying to minimize this problem. So நம்ம என்ன பண்றோம் அப்படினா, sir, if the first alternator, this is the person and who is getting affected by a large disturbance, இத ஒரு single alternator ட்ரீட் பண்ணியாச்சு. Now from this huge disturbance will be scattered to all other alternators, and the all alternators group பண்ணி treat them as a single alternator. Then that analysis will become easy. So if you see in our stability analysis, always we are going to consider only two alternators. It does not mean that we are going to consider only two alternators. The actual meaning is there are thousands and thousands of alternators are connected in parallel, but those alternators are grouped together and they are assumed to be a single alternator. So now we are going to check. Now we are going to take this group, one single alternator, one group of, that is group 1, group 2. If group 1 is getting affected by the large disturbance, how that large disturbance will be spread to the group 2. அப்ப அந்த ஒரு group 1ல ஒரு 4-5 ஆல்டர்னேட்டர் வந்து ஒரே டைம்ல வந்து ஒரு பெரிய டிஸ்டர்பன்ஸ் வந்து எக்ஸ்பீரியன்ஸ் பண்றாங்க அப்படினா, அந்த 4-5 ஆல்டர்னேட்டர்ல இருந்து அந்த டிஸ்டர்பன்ஸ் மத்த ஆல்டர்னேட்டருக்கு எப்படி ஸ்ப்ரெட் ஆகுது? That is called coherent and incoherent operation. That is the next concept. Now, sir, what do you mean by coherent and incoherent? So the conclusion is, guys, listen. Now, let me take two group of alternator. Now, group 1 is experiencing the large disturbance. Now, the disturbance will be spread to the group 2. Now, if the both set of alternators are experiencing the disturbance in the same direction, like my alternators group 1 all are rotating in the clockwise during the disturbance. Now that disturbance will be spread to group 2. Now group 2 also during the disturbance rotating in the clockwise. Then what is the conclusion? Sir, both the set of alternators are rotating in the clockwise during the disturbance. So they are experiencing the disturbance in the same direction. Of course, that is called coherent operation. Now second case, first alternators during the disturbance, group 1 experiencing the huge disturbance in the counterclockwise direction. Now this disturbance will be spread to group 2. Now group 2 will experiencing the disturbance from this group 1, but the disturbance will create the opposite rotation to this first group. Like first group alternators are rotating in the clockwise, second group alternators are rotating in the counterclockwise. Then such a case is simply called incoherent operation. So the conclusion is, totally we are going to see two type of operation. So during the disturbance, if the set of the alternators are experiencing the disturbance in the same direction, all alternators are experiencing the disturbance in the same direction, then that is called coherent operation. If the disturbance experienced by the alternators are group 1, group 2 are experiencing the disturbance in the opposite direction, then that is called incoherent operation. Okay sir? Now during the disturbance, our machine is started swinging. Swinging in the sense, on the rotor side, we have a problem. The problem is, because of the abnormal condition of our power system, your system is going to transient state. Transient state in the sense that is called dynamic state or angular stability. I told you, so we are in the transient zone. There will be sudden disturbance. The disturbance is very huge. That huge disturbance will going to affect the alternator suddenly. Now because of this sudden disturbance, what will happen inside the rotor, right? I know my alternators are rotating at a synchronous speed. Slowly observe all the things that I am giving now, right? Now usually in our rotor we have two structures, right? That is two speed. Actually, your rotor will rotate at the synchronous speed. Actually, this is called mechanical rotation, but it will rotate at the synchronous speed. It will be represented as WMS, right? So, mechanical speed of the rotor, mechanical in the sense rotor, right? Now, that rotor will rotate at the synchronous speed, whereas there is one more field that is called speed of electromagnetic field, that is called omega ES. Clear? Now, what is the difference between these two guys? Both will rotate at the synchronous speed in our alternator when they are in steady state. When they are in steady state. Of course, under their electrical speed in angular representation, their speed relation. That rotor frame rotor rotating frame the resultant electromagnetic, that is resultant MMF, magneto-motive force, right? We will see in alternator, we will see what we mean by magneto-motive force and what is the difference between resultant MMF and stator MMF, rotor MMF. That things I will deal in synchronous machine, not here. Now, should try to understand in our electrical machine inside of the alternator we have an angle, that is the rotating angle. Now, this rotating angle can be first off. Let me take as a reference of synchronous speed axis omega st plus del. That is the del is nothing but the angle difference between the resultant MMF and the rotor MMF, right? Now, this is the general representation of angular difference between the speeds. My rotor frame and my rotating magnetic field. Okay, fine, sir. So that is the general representation. Still, the value of del is constant under steady state or stable zone. Under steady state or stable zone. Now, what will going to happen? Whenever your system is undergoing to transient state, now there will be some changes in my speed of the system. So the angular displacement, right? So in my theta electrical angle will be changed, right? Now meaning see this electrical angle due to the acceleration. Machine because of the large disturbance, machine here new changes will be appeared. That is the new theta E can be written as omega st, that is the rotating speed, synchronous speed of the machine, plus del rotating angle, that is the phase angle difference between rotating MMF, rotor MMF and the resultant MMF, resultant rotating magnetic field MMF, right? So that is the value of del now. With this, we have one more changes. Let me call it as del. What do we mean by here? So because of the changes in my rotor structure, rotor speed rotor MMF resultant MMF a new angle will be produced under transient zone. Okay, rotor first problem is machine for an example, if my machine is some steady state, it is started swinging, it is started accelerating and it is started deaccelerating and it is started accelerating, deaccelerating, accelerating, deaccelerating, accelerating, and then it will be settled down into steady state. Anyway, after some time again your system is going to be what? And it will be settled down into the steady state only, there is no problem. But the problem is the first swing abina, our machine only the disturbance affect upper create a swing first swing. That first swing effect is very higher than rest of swings. So always during the transient zone, my system is getting affected by some external causes. So because of that, what will happen? Your system is your machine started accelerating and deaccelerating in the transient zone. So during the acceleration and the deacceleration, your rotor frame it will start rotating like this, right? Accelerating, deaccelerating, accelerating, deaccelerating, and then slowly again it will be settled down into steady state. Okay. So what is the conclusion here? But sir, how many swings we are going to consider here? We are going to consider only the first swing. Why? Because in the first swing only, your effect will be very huge, and then your swinging is started reducing, your system will be slowly stabilized. So to know the worst case, to know the worst severe, right? Maximum disturbance varo, right? Worst time the alternator you have to go with the first swing. Okay, so let me go with the first swing. Swinging your machine started accelerating and deaccelerating. Upon the swinging only we have to represent it in terms of a equation that is called swing equation. This swinging will be represented by a equation that is called swing equation. Now, how we are going to develop this single equation? Let me told you. So this representation, this mechanical acceleration and deceleration will be represented in terms of a electrical terms, right? Let me develop the equation for sync, right? Now we are going to how to get the equivalent equation for this disturbance, and then we will talk about coherent operation and incoherent operation. How we are going to find out the inertial constant parameters in coherent and incoherent operation. Let me slowly extend our discussion. Okay, so I hope you all remember these things. Now from this, I would like to do one more thing. Just differentiate this equation twice. If I differentiate this equation twice with respect to t, then what will happen? First time when I differentiate panninga, this omega st will become omega s. Second time differentiate panninga, it will become 0. Two times differentiation. We are going to differentiate this equation two times. One time differentiation will give you omega s. Second time differentiation will going to give us 0. Anyway, delta is constant. That is also going to be 0. Now under transient state, the one and only variable is del, d del. Okay, d del, right? So upon you two times the differentiate panninga, you will get the changes is keep on appearing, right? D square del by dt square. Anyway guys, listen, for our understanding, people are usually, instead of using del, we are using del only, right? Just it is representing small changes in the value of del. So for our terminology representation, we are going with del. If you want to keep delta del, you can keep. There is nothing will be wrong, right? So just I am changing this terminology as del only, but don't think this del is this del. Both are not same. First, for our understanding, we are going like this. So what I have understood here, the changes in the value of del will be represented in terms of electrical degree. That is called acceleration or deceleration. Your machine is, we know this is called acceleration equation, right? We know the formula, right, for the acceleration. Now, during this case, what will happen? And let us develop the electrical equivalent equation for this single. Okay, just to remember this equation now. From this, I am slowly developing the equation. Yeah. What will happen now? Now, how we are going to bring this single equation? Guys, listen. Actual machine there are two torque will be developed. Why? Because we are in alternator. So your alternator, first it will develop mechanical power, and then the mechanical power will be transformed into electrical power. Now under steady state. Now what will happen under steady state? So this mechanical power will be developed with the help of mechanical torque, and then it will be transformed into electromagnetic torque. And here correspondent power, for electromagnetic torque, your correspondent power is called as electrical power, right? So there is electromagnetic power, electrical power that will going to be delivered from the alternator, right, with the output port. So the conclusion is under steady state, the mechanical torque and the electrical torque both are going to be equal. If I subtract, right? So if I subtract the mechanical torque minus electrical torque, both are equal. That is called accelerated torque. That is going to be 0. Now what I am trying to conclude, if my machine is going to be, that is if your machine is running under steady state and exactly it will running at synchronous speed without any issues, right? Without any issues, if it is running under steady state, in such a case the mechanical torque developed by the machine and the electromagnetic torque are going to be equal. So the system will be in steady state and the mechanical power developed by the machine and the electrical power machine developed by the machine are going to be 0. So there is no work for acceleration or deceleration. When your system, this is called accelerated power. This is nothing but amount of inertia power. That is the amount of power that will be stored in terms of inertia in our, that is kinetic energy. We can call it as kinetic energy, right? So that is the amount of kinetic energy that will going to be stored inside the alternator itself. Should try to understand, guys. Alternator will develop mechanical power. That mechanical power will be completely converted into electrical domain. So mechanical power will be converted into electrical power and that will be delivered to someone. That is the purpose of alternator. Now during the large disturbance, your mechanical power might become greater than electrical power, or at sometimes electrical power will become greater than mechanical power. So case number 1, let me take mechanical power for understanding, for assume during the disturbance, right? During the transient state, this is the steady state. During transient state, sir, my mechanical power in somehow, some way, due to some abnormal condition, mechanical power suddenly will become greater than the value of electrical power. Actually, what it does mean? First, you have to understand these terminologies. Guys, listen. Electrical power, we are receiving at the terminal. From the terminal, we are going to collect the power from the alternator. Whereas mechanical power is nothing but the power developed by the alternator with the help of prime mover. In the sense, your prime mover will rotate at constant speed. So the mechanical power developed by the prime mover is always constant. You are unable to change the mechanical power of the alternator at any cost. So this mechanical power is always constant. But based on the variations in the output terminal, what will happen? Suppose in the alternator terminal, suddenly there will be a short circuit. Now what will happen? Output power is going to be 0. Now due to some malfunctioning, electrical power that we are receiving from the alternator output terminal, there will be some malfunctioning might be happen. This is my alternator. In this output port, if your output port is suddenly getting open circuited, then what will happen? Current is going to be 0. Then what will happen? Power will become 0. Or your open port, your output port might be suddenly getting short circuited. Short circuit voltage is going to be 0. Again your power will become 0. So what is the conclusion here? So the conclusion is, during this abnormal condition, in the output port your electrical power is tremendously changing. It is keep on changing. But if you observe the mechanical power, at any cost, mechanical time constant is always very high. Like our temperature. Temperature time constant also very high. They won't accept the sudden change easily. They will take tremendous time. They will take more time to accept the changes. So, though there is a fault in the external side, though there is a fault in my alternator output terminal, that fault does not affect the internal mechanical speed or internal mechanical power developed by the alternator. So, what is the conclusion? If I am writing mechanical power is greater than electrical power in the sense, electrical power might be reduced. For your understanding, initially your mechanical power is 10 megawatt. Of course, electrical power also 10 megawatt. In this case, both the electrical power and mechanical power are equal. So 10 minus 10 is going to be 0. That is steady state. Now, due to some abnormal condition of my alternator, in the output port, electrical power will be gradually reduced to 10 megawatt to some 7 megawatt. In resultant, what will happen? Still my mechanical power is constant because mechanical time constant of the rotor is very high. You cannot change the mechanical power or mechanical torque easily, but you can change the electrical power because electrical variations could be possible. That is in the output terminal of the alternator. So, due to some abnormal condition, my electrical power is suddenly reduced to 7 megawatt. Now, if I will compare, mechanical power still 10 megawatt. You cannot change the other mechanical power. But under steady state, these two guys are always equal under steady state. But due to abnormal condition, now your electrical power become only 7 megawatt. So 10 minus 7 will become 3 megawatt. What I am concluding here, mechanical power developed by the alternator cannot be changed though your system is getting affected by some abnormal condition because of the time constant, high time constant. Mechanical power remains constant, whereas the electrical power might be reduced or it might be increased. There are two cases. Now I am going into case number 1. If the mechanical power, in this case electrical power is reduced, then the mechanical power will become greater than electrical power. In such a case, mechanical power is greater than electrical power, then your accelerated power will become positive. In the sense, what I am trying to conclude, 10 minus 7 is going to be 3 megawatt. That is positive value only. That is the extra amount of power. Actually, now my alternator is generating 10 megawatt. But in the output terminal, the person is consuming only 7 megawatt. Now, alternator, I am delivering 10 megawatt, but there is no persons to consume 10 megawatt. Only 7 megawatt will be delivered. So the rest of 3 megawatt will going to be stored inside the alternator, inside the rotor. That is called kinetic energy. This kinetic energy you can observe inside the alternator when there is a fault. Under steady state, your power will be completely utilized by the consumer. 10 megawatt will be completely delivered. But during the fault only, we are facing this problem. So the conclusion is, mechanical power is going to be greater than the electrical power. Your machine is started accelerating. Sir, if the value of mechanical power, suppose suddenly due to some issue, some abnormal condition, electrical power will be suddenly raised to 12 megawatt. Such cases will be possible. It could be possible, let me tell you later on, okay? Not now. So, this 10 megawatt will be suddenly raised to 12 megawatt. Then what will happen? Again, 10 megawatt is less than 12 megawatt, no? So, now in second case number 1, mechanical power will become greater than electrical power. So, the overall power will become positive and 3 megawatt. So, your machine is started accelerating if it is positive. Suppose the mechanical power will become electrical power. Guys, observe. In both of these cases, I am changing the value of electrical power. I am not touching your mechanical power. That is constant. So in this case, electrical power is going to be what? It is gradually reduced, right? Sorry, if it is increased. So in such a case, what will happen? The overall power. Once again, the overall power or your machine is going to be deaccelerated. That's all. So that is the difference between acceleration and deacceleration, of course. So what is the conclusion? Finally, whenever my machine is undergoing to disturbance, right, is undergoing to abnormal condition. So my machine is it had a swinging. That is had a swing. That swing is we are going to consider only first swing to do worst case analysis because first swing is the worst value, very big value. So I am going with the first swing, and the second case is during this swinging I have two things. One is acceleration, other one is deacceleration. Now that acceleration and deacceleration, I am deriving it in terms of electrical power, right? Electrical relations. For that, we are discussing about the alternator property. In our alternator, we have two power. One is mechanical power and electrical power. If they are equal, then your system will be in steady state. If they are unequal, then your system might be accelerated or deaccelerated. You can observe this unequal power, or acceleration or deacceleration. during the transient state, when your system is getting affected by the large disturbance. That's all. Now let me develop the equation, swing equation, right? Now how we are going to develop this swing equation? Basics are over. Let me slowly develop the swing equation. So let's see what will happen. Guys, this is a swing equation. For that, I am taking the accelerating power of the alternator. So usually this alternator accelerated power can be written as mechanical power minus electrical power. Of course, that is correct. Now my system will be in what? Transient state, right? Your system will be in transient state. Yeah, I'm really sorry, small disturbance. So your system will be in transient state. Under this case, what will happen? This is the accelerated power. So sorry, accelerated torque. Accelerated power will become what? I can write accelerated mechanical power minus electrical power. I have a difference. Steady state no problem today. We are in transient state. Definitely now I am going to get some different values. Let me develop the equation slowly. This accelerated power, that is accelerated torque, mechanically can be written as. Let me develop the equation. So first I have to write this in terms of acceleration. Acceleration in the sense what I am going to do now. Your machine is going to be accelerated, that is inertia, right? Moment of inertia that will be considered in our machine into d square, mechanical speed, d square theta m divided by dt square. That is the acceleration of the machine, right? In the force equation, acceleration, force, right? That is what I am doing. This is accelerated equation, I know. So let me slowly extend the discussion. From here, what I am going to do? J times of d square by dt square. Of course, that is correct. But we all know this mechanical theta can be written as 2 by p times of electrical theta, electrical degree. This is mechanical degree. This is electrical degree. I will tell you this difference in between alternator. That is in between these two guys in alternator. We will see. The electrical machine is not here. Right now, normal generation. Let me substitute it here. Then what will you get? Or you might be studied electrical machines. You might be see this. You might have seen this equation. So theta m can be replaced by theta e into 2 by p. Let me keep 2 by p is constant where p denotes the number of poles, right? So you can take it out. So what I am going to conclude here from this is my accelerated torque. Now let me extend the discussion. Just equate these two equations. From this I can say j times of d square theta e by dt square into 2 by p can be written as equal to what? Mechanical torque minus electromagnetic torque. Now in the next step, now on the both side of this equation, I am going to multiply by mechanical speed, that is mechanical synchronous speed, and this is rotor rotating, mechanical rotating speed, and it will rotate at a synchronous speed. Now mechanical speed, if mechanical theta can be replaced by 2 by p into theta e, then the mechanical speed at the synchronous, it can be replaced by 2 by p times of electrical speed at the synchronous. Same relation. Let me substitute it here. Then what will you observe? You will get here 1 2 by p. Already one more 2 by pi is there. So 2 by p whole square. 1 j is here. With we have electrical speed at synchronous, right? D square theta e divided by dt square equal to here. Guys, listen, mechanically torque into omega. That is nothing but what? Power, right? So it can be written as accelerated power, mechanical power minus theta e, that is electromagnetic torque with respect to speed, that is called electrical power, right? So in the next step, this total term, let me introduce the next term, that is called inertia constant m, right? So this total term will be replaced by inertia constant m. So the inertia constant m can be simply written as j times of, guys, this is very important. I am introducing the inertia constant. Since all these values are going to be treated as simply inertia constant m, and let me know, and just playing with some mechanical derivations, right? So should try to keep it in your mind. So let me replace this total term by m. So next step it can be as m into d square theta e divided by dt square equal to mechanical power minus electrical power is known as accelerated power. We know that is called accelerated power. This equation is simply called what? Power equation, right? That is the swing equation. But swing equation in the sense, this is electrical speed. I have to write this equation in terms of del now, because during the transient zone, my theta is changing with respect to what? Del only. Because initially it was constant, it does not vary with respect to anyone. Under steady state, small perturbations are there that can be neglected. But because of these changes in the value of del, there will be a deep changes in the value of theta e. Actually, there is electrical speed only, no? So that can be replaced by d square del by dt square. That is the finalized swing equation. So swing equation can be simply written as m into d square del upon dt square is equal to accelerated power or mechanical power minus electrical power. So this is generalized swing equation. This swing equation will going to help us to identify the swinging in our system, about to know about equal area criterion and everything can be predicted with the help of this swing equation. That is the most important term. Clear? So don't forget. So this swing equation is going to play a role, because now this swing equation நம்ம என்ன பண்ணிருக்கோம், mechanically swinging will be there inside of the machine. Swinging will be there. That swinging can be predicted, that can be analyzed with the help of this swing equation only. Clear? I hope you all understand what I am trying to control. And the next thing is, this electrical power can be written in one way. Actually, what do we mean by this electrical power? The alternator delivered power, output power of this alternator is nothing but this electrical power. This electrical power can be written like this. Let me write. Actually, this electrical power can be written as, electrical power PE can be written as P max into sin del. That is the actual formula. You might have studied these things in our alternator output power equation. So here P max is nothing but it can also be called steady state stability limit power equation, right? So that is the maximum power handled by the alternator, right? So it can be written as generator voltage of the alternator and the terminal voltage of the alternator divided by the reactance offered by the alternator. Clear? So alternator, what are the things that I am going to consider? You can consider transmission line. So that is the output terminal, that is the reactance offered by the system. Let me consider from the alternator. Okay. So this is the overall generalized formula. So the electrical power can be written like this. Now this electrical power, if the electrical power meaning a curve varying with respect to del, if I develop the equation, this is my electrical power with respect to del, this equation will become like this, because it is a sinusoidal curve. Yes or no? Yes sir, of course that is sinusoidal. But what is the maximum limit? Guys listen, I only told you there are two states. One is steady state, another one is transient state. In steady state, small perturbations are there, disturbance there. Whereas in transient state, large perturbance, large disturbance will be there in our system. So let me take first in steady state. Suppose if you are in steady state, stable state, small disturbance. With that, you can increase the value of del up to 90, because this is del equal to 90. Sinusoidal curve 0, 90, 180. I am considering first half. So I can increase the value of del from 0 to 90, so that we are obtaining at del equal to 90, your P will become P max. We are obtaining the maximum power in our system. If I am trying to go beyond 90, then my power is keep on decreasing. So under steady state, the maximum value of del is 90 only. So if your system will be in steady state, then you are supposed to go from 0 to 90 degree. This is for steady state. Suppose if I am talking about transient stability. In transient stability, what will happen? Actually, in transient stability, the value of del is changing. You will go beyond 90. Guys, listen. System வந்து என்ன இருக்கு அப்படினா இப்ப 0 ல இருந்து 90 வரைக்கும் some small disturbance ஓட ஒரு run ஆயிட்டு இருக்கு. But suddenly a large disturbance will be there. Then what will happen? Rotor frame will be forced to go beyond 90. Then what will happen? The value of del will cross 90, but it won't be live. It won't be standard. 90 க்கு மேல போயிட்டு அங்கேயே இருக்காது. It will getting back. Because what I told you, during transient, system will be acceleration, deaccelerated, swinging slowly decreases, at last it will become steady state, but the settling point will become less than 90 once again. So even in transient stability also, the resultant value of del is going to be less than 90 only, because 0 to 90 only my power will be in stable zone. If I go beyond that, my power is keep on decreasing, that is unstable zone. That is not acceptable values here. So here what I am trying to control, from 0 to 90 stable state, of course in transient zone I can go beyond 90. I will go beyond 90, but I won't be standard. I won't be settled down into the value of del. That is del only greater than 90 போயிட்டு திரும்ப it is getting back. I won't be settled there. நான் அங்கே செட்டில் ஆக மாட்டேன். 90 க்கு மேல போயிட்டு அங்கே நான் நிக்க மாட்டேன். I am getting back. Right? So this is 90. Assume this is 0, 90. I will go beyond 90, but I will getting back. Right? First swing. And then again I will go beyond 90, but slowly, and then finally I will be settled down into 0 to 90 only. So in transient zone, the value of del might go beyond 90. It has the possibility to go greater than 90, but it won't be settled beyond 90. It will getting back under steady state. The value of del will become once again 90, less than 90 only. It won't be settled beyond 90. And the transient stability வரும்போது சடனா போகும், பட் அங்கே நிக்க திரும்ப வரும். அந்த கொஞ்சம் கொஞ்சமா டிஸ்டர்ப் ஆயிட்டு அதுக்கு அப்புறம் செட்டில் ஆகும். less than 90 தான் செட்டில் ஆகும். Okay, that's all. So what is the conclusion? In transient state, there might be a possibility for them to go beyond 90. Clear? So that is all about electrical equation. So this electrical power can be written like this. Now why I am defining this all things here? I only told you electrical power can be varied here. With the help of this electrical power variation only, your machine is going to be accelerated, your machine is going to be deaccelerated, because usually due to high mechanical inertia constant, due to high time constant of the mechanical domain, your alternator prime mover, so time constant is very high, they won't change, they won't accept the sudden changes, so the mechanical power are almost constant, it won't be varied. So but there may changes, electrical power is the variation, right? So this electrical power only will going to create the demanded changes in our system. Of course sir, this is correct. So next what I am going to do, now we have to see, நான் இப்ப என்ன சொல்லிருந்தேன் அப்படினா during the disturbance, அப்ப the disturbance வரும்போது mechanical power of the alternator might go beyond what will happen electrical power. So electrical power வந்து suddenly reduce ஆயிடுச்சு, ரெண்டு பேரும் 10 megawatt, no problem. Electrical power will reduce to 7 megawatt, 10 minus 7 will become 3 megawatt. That extra megawatt energy, that is extra megawatt with respect to time is known as energy. That energy is called kinetic energy. That energy will be stored inside the alternator. Let me estimate. அப்ப during transient தான் இந்த problem வரும். System steady state இருந்தா kinetic energy வேற கிடையாது, the electrical power, mechanical power will be converted into electrical power. But what will happen during the disturbance? Because of the disturbance, what will happen? My system, right? My system had a problem. Now what will happen? Let me take the kinetic energy that will be stored in terms of kinetic energy during the transient. Mechanical power might become greater than the electrical power. Electrical power sometimes will become greater than the mechanical power. So your machine is going to be accelerated and deaccelerated. I know that things will happen in my system. So the confusion is kinetic energy can be written as of J mechanical speed, right? Mechanical speed of the machine, but it is rotating at the synchronous speed. So this is the kinetic energy formula. Let me extend the discussion of J mechanical speed can be written as what? 2 by P times of electrical speed. Since we have square, so that is become square. But just now we saw of J times of 2 by P whole square into 1 electrical speed can be replaced by M. So let me write it M times J times of it will be replaced by M into electrical speed at the synchronous. That is the omega electrical speed but rotating at the synchronous speed. Okay, this is the kinetic energy equation. Now this is one type of inertia constant. Okay, another one is there will be one more inertia constant. The same kinetic energy will be written in the alternative way. So that is the base MEA into another one inertia constant H. Guys, listen, these two inertia constants are very important, right? Let me define. So ரெண்டு பேருமே inertia constant அப்படிங்கறது தான் நேம். ஆனா எக்ஸாம்ல வந்து எப்படி கேட்பாங்க அப்படிங்கறத நான் சொல்றேன். ஃபர்ஸ்ட் இத அப்சர்வ் பண்ணுங்க. This is treat this one as a equation number 1, treat this one as a equation number 2. Now from this inertia constant can be written as kinetic energy divided by G. G is nothing but MEA, base MEA, right? Whereas kinetic energy it will be in megajoules, right? Your joules will be generated in megajoules because a big size of alternator will be there, right? So the conclusion is inertia constant, this inertia constant H can be defined as megajoules per MEA. அப்ப எக்ஸாம்ல क्वेश्चन கேக்கும்போது find out the inertia constant in megajoules per MEA கேட்டாங்கன்னா they are talking about inertia constant H. Clear? அப்ப M க்கு எப்படி சார் கொடுப்பாங்க? Let me take, so just equate the equation number 1 and equation number 2. இவங்க ரெண்டு பேரும் நீங்க ஈக்குவேட் பண்ணீங்க அப்படினா when I am equating 1 and 2, treat this one as a equation number 3. Very important equation, don't forget. Clear? Now if I equate these two guys, then what will happen? Of M omega ES is equal to GH. From this I can say this inertia constant can be written as GH. 2 will go there, this 2 will go there. Omega can be replaced electrically, it can be written as 2 pi f. Now 2 getting cancelled out, it will become GH divided by pi into f. Okay, let me define the units. Guys, listen. Just now we saw G unit is what? MEA, right? Unit of G is MEA. What about the rest of people? Yeah, unit of G is MEA into, what about H? Inertia constant H can be written as megajoules per MEA. In the denominator, phi can be written as electrical radiant. That is the unit of phi. Whereas 1 by f na t, time period t, அப்ப அதுக்கு பதிலா நம்ம seconds னு எழுதிடலாம், கரெக்ட்டா? So MEA getting cancelled out. So the unit of M is going to be megajoules second for electrical radiant. Okay, அப்ப எக்ஸாம்ல கேக்கும்போது find out the inertia constant M அப்படினு கேட்டிட்டு பிராக்கெட்ல என்ன கொடுத்திருப்பாங்கன்னா in megajoules second for electrical radiant அப்படினு கொடுத்திருந்தாங்க. They are talking about M. Suppose the unit is given as megajoule per MEA, then they are talking about H. That is the difference between these two inertia constants. Okay, so let me extend the discussion. This electrical radiant can also be written in terms of electrical degree. இது வேற எப்படி எழுதலாம் அப்படினா This m equation can also be written as gh by this 5 can be replaced by in degree can be written as 180 na, so 180 into f. So again we are going to do megajoules. Second one is in the numerator there is no change, but in the denominator electrical degree can be written as electrical degree. There are two ways you can ask this question, right? So if you are asked to write the answer in megajoules second for electrical degree, then this is the formula. If it is asked, if you are asked to find out the answer in megajoules seconds per electrical radian, then this is the formula. Clear? So that is how we are finding the value of inertial constant h and inertial constant m of a single alternator when it is experiencing a large disturbance. Okay. Yeah. So listen, apart from from the beginning onwards, I was telling that there are two group of alternator. If one group of alternator is experiencing a large disturbance, that disturbance will be scattered to the another alternator. So both group of alternator together will experiencing the disturbance, right? Now how the disturbance will be registered? See, equation because of the disturbance, what will be the overall inertial constant? M oda motta value enna varum when two alternators are experiencing the disturbance together. Guys, listen, actually I only told you நம்மளால வந்து thousands and thousands of alternators ஒண்ணா எடுத்து பார்க்க முடியாது. So அதனால நம்ம என்ன பண்றோம் அப்படினா we are going with the relations. என்ன relation? I will take sir one set of alternator here and there will be one more alternator in between. I have grid. Actually it means group of alternator. The first group of alternator experiencing the disturbance in clockwise, of course, then second alternator is also going to experiencing the disturbance in the clockwise. That is called coherent operation because both alternators are experiencing the disturbance in the same direction. In resultant, what will happen? In resultant, the changes in the value of del in alternator 1, let me call it as del 1. The changes in the value of del in the alternator 2, let me call it as del 2. Both people are experiencing the disturbance in the same direction. So the overall del will become del 1 plus del 2. Clear? Why? They are aiding each other. So aiding in the sense addition. They are experiencing the disturbance in the same direction. In such a case, the swing equation can be written as swing equation of m into d square del by dt square is equal to accelerated power Pa, that is our swing equation, or Pm minus Pe. I know that one. From the second right, if del is equal to del 1 plus del 2, then the swing equation can be written as m equivalent is equal to, this is a del equivalent. அப்ப இது என்ன வரும்? m equivalent into d square del equivalent divided by dt square equal to it can be written as m1 into d square del 1 by dt square for the first machine plus m2 into d square del 2 by dt square for the second machine. Of course this is correct only, but the thing is, since both group of alternators are experiencing the disturbance in the same direction, in the sense in the rotating frame almost the value of del 1 is equal to del 2 only. So I can say del equivalent is nothing but del 1 equal to del 2. எல்லா alternators என்ன பண்றாங்க? experiencing the disturbance in the same direction. So that disturbed value also will be remain same. Rotating frame குள்ள resultant mmf க்கு rotor mmf க்கு நடுவுல இருக்க phase angle disturbance எப்படி இருக்கும் அப்படினா almost equal. Clear? So I can say from this it can be simply written as m equivalent into d square del by dt square because del equivalent del 1 del 2 all are equal. Let me simply make them del. எல்லாரும் del தான், right? So simply I can write as m1 plus m2 into d square del by dt square. Yes or no? So these two people are getting cancelled out. So the overall value of m equivalent will become m1 plus m2. So the question is, in coherent operation you are supposed to calculate the overall m equivalent, right? M equivalent in unit என்ன? megajoule second per electrical degree or electrical radian. There are two way. எதை கேட்டாலும் ரெண்டு மெஷினை கொடுத்துட்டு coherentல இருக்கு. அதுல m equivalent என்னன்னு கேட்டாங்கன்னா this is the formula. Suppose h equivalent கேட்டாங்க அப்படினா இந்த ஃபார்முலால இருந்து நீங்க h equivalent கால்குலேட் பண்ணலாம். எப்படி? Take this equation. m equivalent can be replaced by g equivalent h equivalent divided by 180 f or pi into f equal to, just I am replacing m by this derivation. In this step I am substitute பண்றேன். அப்ப m1 தான் எப்படி எழுதுவீங்க? m1 in the sense MA rating of alternator 1, inertial constant of the alternator 1 divided by frequency remains constant, right? Plus MA rating of the alternator 2, inertial constant of the alternator 2 divided by pi into f. Anyway, pi f getting cancelled out. Finally, I can say the value of g equivalent is going to be g1 h1 plus g2 h2 divided by common base. Common base will be given. Actually, I will need of h equivalent here. G equivalent and the pass common MEA rating will be given to you, right? Now with the help of this you can find out the overall H equivalent for your coherent operation. Anyway, in incoherent operation you are supposed to calculate the value of M equivalent only, you are not supposed to calculate the value of H equivalent. For incoherent, this is coherent. In the formula kandipa keppanga. Incoherent lengthy formula will be there, you cannot go with that one, time consumption will be more, so you might be asked to find out the value of M equivalent. H equivalent you cannot expect in incoherent operation. Anyway, first I will derive the expression for M equivalent. If you want, you can derive it in the same approach. You can derive H equivalent if you want. Okay, I will derive only for M equivalent because that is very important in an exam point of view. And the second thing also, you can derive it by your own, right? In the same way that I have done here. So, what do we mean by incoherent operation? First of all, listen. In incoherent operation, what I am supposed to do here, right? In incoherent operation, two alternators are, that is two group of alternators are connected together. Of course, that is correct only, sir. With our infinite bus bar, there are two alternators or two group of alternators are connected together. But if the first alternator is going to rotate, first group of alternators are rotating in the clockwise, second group of alternators is going to rotate in the counterclockwise direction. From this, I can say both group of alternators are opposing each other. In this case, guys, listen. Suppose if you are alternator, if you initially normal condition, alternator is rotating in the clockwise. Now during the disturbance, if the alternator will rotate in the counterclockwise, then the alternator will become a motor. Why? It is rotating in the counterclockwise direction. Initially it was working as an alternator. Now the direction is reversed. So one group is going to work as an alternator, another one group is going to work as a motor. Right? Now what we know, motor will absorb the power from the alternator. So in this case, the real power transformation will vary in pace from alternator 1, from group 1 to group 2. Why, sir? Group 2 people are working as a motor now because of the disturbance, because they have started rotating in the opposite direction to the first group. Because of this, they are being treated as a motor and they are consuming the power from this group to this group. And the second thing is, if you are working as an alternator, in such a case, you will have some value del 1 and they are rotating in the opposite direction, definitely they will get some other value. These values are not equal because in our previous case, in coherent operation, all the alternators are rotating, all are working as an alternator, all are experiencing the disturbance in the same direction, so that the value of del also will become same. But in this case, they are rotating in the opposite direction. One group is acting as an alternator, another group will going to work as a motor. So definitely the changes in the del will not become equal because one set is alternator, another set is motor. I cannot merge the group of alternator with the motor. We cannot say that statement is wrong now. So the conclusion is, the overall value of del will become del 1 minus del 2. Why, sir? Both are opposing each other. See the opposite direction. So in this case, once again, we all know this equation can be written as m into d square del by dt square should be equal to accelerated power Pa. In the next step, d square del by dt square can be written as accelerated power Pa divided by inertia constant m. Of course, this is correct, right? Now from this, what I am supposed to do? If del is equal to del 1 minus del 2, then this one can be written as d square del, let me write like this. Then this one can be written as, and there will be writing Pa1 divided by m1 or Pa equivalent divided by m equivalent is equal to, for this I am writing, this is del equivalent. For this del equivalent, this is the equation. This is substitute equal to Pa1 divided by m1 plus Pa2 divided by m2, right? In the next step, what we know, sir, we all know. What we all know, accelerated power can be written as mechanical power minus electrical power. Of course, that is correct, sir. So with this help of this, let me substitute. Appo idhukku bara minus substitute panikalam appadina Pa equivalent, that is accelerated power equivalent divided by m equivalent is equal to, let me replace, Pa1 can be written as Pm1 minus Pe1 divided by m1 plus Pm2 minus Pe2 divided by m2. But in the next step, guys, listen, one group is acting as a motor, another group is acting as an alternator. If this group is developing the power is called Pm1, then this group developed power is called Pm2. Both are in the opposite direction, but they are consuming together. This person is supplying, this person is consuming. So both are going to be equal in the opposite. So I can say, and the power delivered by the alternator one is Pe1, power absorbed by this group is going to be Pe2. Since it is delivering, it is absorbing. Same power, it is delivering, it is absorbing, but they are in the opposite. One is delivering, another one is absorbing. So what I can say, from this I can write this statement, Pm2 is equal to Pm1 only, but in the opposite direction. Why? One is delivering, another one is absorbing. Similarly, Pe2 can be written as minus Pe1. Now substitute these two values into the equation, then you will get accelerated power, equivalent accelerated power divided by m equivalent can be written as Pm1 minus Pu1 divided by m1 plus Pm2. Pm2 can be replaced by minus Pm1, okay, minus of Pu2 can be replaced by, actually in between this we have a minus, because in the formula we have minus, right? So this is minus, not plus, sorry, I made mistake. Of course, this is minus only. Yeah, this is minus Pm1, minus of Pu2 can be replaced by minus Pu1 divided by m2. Yeah, in next step what we observe, if in the minus now open பண்ணிட்டு dash is Pm1 by m1, minus of minus become plus Pm1 by m2. So இப்போ எப்படி எழுதலாம்? Pm1 into 1 divided by m1 plus 1 divided by m2. Similarly, second step, minus Pu1 by m1, minus of minus into minus will become again minus. So minus நீங்க வெளில எடுத்தீங்க அப்படினா minus Pu1 in bracket I can write 1 by m1 plus 1 by m2. Is there any mistake? No sir, of course this is correct, right? So finally what I am trying to conclude here, so from this, so I can write like this, 1 by, you can take 1 by m1 plus 1 by m2, that is the value of m equivalent. Of course this is correct, right? So இது வெளில எடுத்தீங்க அப்படினா இங்க உங்களுக்கு ரிலேஷன் என்ன வரும்? Pm1 minus Pu1, this is nothing but accelerated power. So here also I have accelerated power only divided by m equivalent. So the conclusion is these two guys are getting cancelled. Why? Pm minus P nothing but accelerated power. So by m equivalent we will draw finally 1 by m equivalent can be written as 1 by m1 plus 1 by m2, right? From this the value of m equivalent will become m1 into m2 divided by m1 plus m2. Clear? So that is the overall m equivalent. Guys, from this if you want to find out the value of h equivalent, but you can find, but in the exam definitely you cannot expect these things because there is the derivation. H equivalent calculate, right? So that is all about incongruent operation. Now I hope you all have get a very clear idea about incongruent and congruent operation. Now the second part of this stability analysis we will see in our next video. Thank you all.